For this one, we're going to continue our discussion of comparing permutations and combinations, but we're going to try to find all four of these without a calculator. So again, the theory behind what a permutation and combination is saying. So in part A, 4 permute 4s, what's that saying? Permutation of 4 objects taken at 4 at a time. If you want to imagine you have 4 blocks on the ground, A, B, C, D, and what part A is saying is, of the 4 blocks, you're going to pick up all 4 and arrange them where order matters. Remember, permutation is where order matters. So what does that mean? How many ways can you do that? You have 4 blocks on the ground, you're going to pick up one at a time. And the order in which you pick them up is very important. How many possible outcomes are there? What'd you get? 24? Good. Because, let's think about it. Here's our 4 blocks. How many ways can you pick up the first block? 4. And the second block? And the third block? And the last block? Well, 4 times 3 times 2 times 1 is 24. Notice that is also 4 factorial. So as it turns out, a permutation of n objects taken at a time is n factorial. All right, that's the tough one. The next ones hopefully aren't that bad. Now in part B, a combination of 4 objects taken 4 at a time where order does not matter. Well, a combination of 4 objects taken at 4 at a time, you have 4 blocks on the ground. You need to pick up all 4, but it doesn't matter the way you pick them up, or the order in which you pick them up, I should say. How many number of ways, are there to pick those up? 1. If order doesn't matter, as long as you pick up all 4, you've done the job. There's only one way to pick up all 4, and that is bending over and picking up all 4. That's it. So as it turns out, a combination of n objects taken at n a time is 1. Now, nothing's going to stop you of using your combination and permutation formulas on a test or a quiz or homework. However, I want you to understand what's going on here. All 4 of these examples are special cases. And if we had any other types of numbers, like if it was 7-3 instead of 4-4, we would pretty much have to use a formula. We could do it by hand with vectorials, but it defeats the purpose of what's going on theoretically. So part C, you have 3 objects on the ground, a block that has A, a B, and a C. You're going to pick up none of them where order matters. That's what this is saying. So 3 objects on the ground, you're going to pick up none of them. How many ways can you do this where order doesn't matter? 1. You just don't pick up any of them. Very good. So finish this. The number of permutations of n objects taken 0 at a time is going to be 1. Likewise, you have 3 objects on the ground. You're going to pick up none of them where order does not matter. How many ways can this happen? Also 1. So a combination of n objects taken 0 at a time is 1. Good. So again, in practice, I can't stop you from using your calculator, but just make sure your answer makes sense. Again, for the same size n and r, you typically have more permutations than you have combinations. You may have the same number as we saw here, but it depends on the values for n and r. You should never have more combinations than you do have permutations.